So what is happening when we have a division with exponents with the same base? So we can divide these because they both have a base of x. We're working with the same group of stuff. You could think of it like of apples and oranges. X is like an apple and y is an orange, and you can't bunch them and cancel stuff out because they're different bunches. So why do we subtract an exponent? So we say the rule is going to be 5 take away 3, which is x squared. Well, what's happening here, let's look at what each one means. X to the fifth means x times x times x times x. So when I would forget on a quiz or test, I would just write that out. It takes a second. Do a problem with small exponents. If you have a problem with big ones, and it'll just trigger your memory of what you're going to do. Subtract or add or multiply. So x to the fifth means x times itself 5 times, like that shows there. X to the third means x times itself 3 times. Right? And when we have 2 over 2, we're allowed to cancel it out because it becomes a whole, right? And becomes 1. So what happens here, x over x cancels out, x over x cancels out, x over x cancels out. How many are left? 2. So the answer is x to the 2. So the reason we subtract the top one from the bottom one is because they would get canceled out. We have to subtract them when you cancel them out. They're no longer there. So what about when you have x to the 1 over x to the 1, right? If we follow that rule, it's x to the 0. 1 take away 1. So then we know anything over itself is 1. We just said 3 over 3, 2 over 2, or 5 over 5. So x over x is also 1. Oops. So if x over x is 1, if we do the subtraction rule, x over x also means 1 minus 1, or x to the 0 power. So that is why x to the 0 power is 1. It's really canceling out the exponent. So x to the 0 power doesn't mean there's 0 x's. It means that there's nothing below, then there's nothing above. They're both canceled out, and it's the whole number 1.